On the morning of June 23, 2020, a rumble shook the heart of the Dalian Mountains. The Long March rocket carrying the 55th BeiDou navigation satellite shot through the clouds and headed for space. A special camera captured the entire process of the satellite unrolling its solar panels. It was the final launch of BeiDou 3, and the whole world was watching. Within 26 years, China had managed to build a global navigation satellite system independently.
要想在穹顶之上布满我们自己的导航卫星，这条路困难重重。回想上个世纪90年代初，我们的国家对于那些受命于建造北斗卫星的科技工作者来说，资金有限，怎么办？我们的工业制造水平能否跟得上？许多的关键性元器件无法自己生产，又该怎么办？迷茫中总是能找到希望的。从两弹一星开始，中国人从不会因困难而止步不前。
To Chinese people, this tune evokes memories of a pivotal moment in the history of China's space project, the launch of Dongfang-Hong-1, China's first space satellite, and part of the country's 2 bombs, 1 satellite project. The moment this piece of music was relayed to Earth from the satellite, the whole country erupted in joy and excitement. Everyone wanted to see the satellite for themselves. A satellite's position in space is always updated to the satellite control system. The satellite control system developed by Chen Fengyun, an expert in radio electronics, adopted Doppler positioning technology, which only the US and Soviet Union were thought to have mastered at the time. In theory, application of this technology could determine a position on Earth via a satellite. In November 1970, 6 months after the Dongfang-Hong-1 was launched, the first report on the development of a navigation satellite was completed. A navigation system with a sample satellite was codenamed the Lighthouse Project. But due to technological and financial limitations, and the direction of aerospace research back then, the project was discontinued. In 1983, a tragic plane crash prompted then US President Ronald Reagan to issue a directive making GPS freely available for civilian use.
Against 269 innocent men, women, and children.
At that time, both the US and the Soviet Union had invested over $10 billion in developing satellite systems for global navigation. At that time, this was a figure that China could not match. Faced with this reality, Chen Fengyun put forward a creative, groundbreaking concept, which later came to be known as twin satellite positioning. Put simply, twin satellite positioning uses 2 communications satellites in geostationary orbit. The position of each satellite is the center of two virtual spheres, with a radius extending between the satellite and the user on the Earth's surface. The position of the user is at one of the 2 points where the spheres intersect. Then another virtual sphere is created, one with a radius extending from a central point at the Earth's core and the user. Then, thanks to this third intersecting sphere, it becomes possible to pinpoint position even more accurately. In order to verify the feasibility of twin satellite positioning, Chen Fangyun took a research group to satellite control stations in Xinjiang, Guangxi and Beijing to carry out experiments between 12 a.m. and 2 a.m. when the two communications satellites were not being used. This photo was taken on September 25, 1989. On that day, China managed to use 2 satellites to carry out a positioning demonstration for the first time. However, more factors had to be considered before a decision could be made on whether the costly navigation satellite project could be launched. In 1990, the world watched as the Gulf War broke out. For the first time, the US carried out strikes using weapons guided by GPS. In their summary report, the Americans called their triumph in the Gulf War a victory of GPS. This modernized war taught China and the world the importance of having a navigation satellite system. In February 1994, a document titled Notice on the Issuance of the Approval Report of Twin Satellite Navigation Positioning System Project marked the official launch of BeiDou 1. That same year, Sun Jiadong, who was already 65 years old, was appointed chief designer of the project. Sun Jiadong studied in the Soviet Union in the 1950s. At that time, he was deeply influenced by the Russian version of Engineering Cybernetics, written by Qian Shuisen. Qian Shuisen had specially appointed Sun Jiadong to be the chief designer of the Dongfang Hong 1. Now there was a new challenge to rise to. Both Russia and the US decided to build a global navigation satellite system capable of pinpointing any and every position on the Earth's surface. In the early stages of the BeiDou project, there was a serious lack of research funds, a technology base and human resources. China had to look for a different technological path forward. With the deepening of application and exploration, the development path was mapped out in 3 steps. Firstly, BeiDou 1 would serve China and become the region's first positioning satellite. Secondly, BeiDou 2 would cover the Asia-Pacific and carry out comprehensive functions including positioning, navigation, time service and communications. And thirdly, a global BeiDou 3 network would be built to serve the world. Since 1994, BeiDou 1 has been turning from a concept into a reality. Multiple subsystems were established, including rockets, launch sites, measurement and control units, as well as ground monitor stations. In October and December 2000, 2 BeiDou 1 satellites entered their present orbit, making China the third country to have a satellite navigation system after the US and Russia. But in its early stages, it was one special function that made people realize BeiDou's great value. On May 12, 2008, Wenchuan County in Sichuan Province was struck by a devastating earthquake. Communications were cut off instantly. Hours later, a rescue team with the BeiDou terminal entered Wenchuan by China National Highway 317 along Ma-er-Kang and He-shui, and sent out messages via the BeiDou short message service system. BeiDou became the only means of communication in the quake-hit region, greatly improving rescue efforts. Other navigation systems did not have this short message service. This was because the twin satellite positioning experiment in the 1980s had been completed with communication satellites. People had found that besides signals, words could also be transmitted through the limited communication channel between satellites and users. Using BeiDou's short message service system, people who work in the sea can send messages to their families at any time. By 2020, over 70,000 fishing boats and law enforcement vessels were using the BeiDou terminal. In the fishing industry alone, more than 10,000 people have been rescued by BeiDou. Many Chinese fishermen now refer to BeiDou as the new Ma Su, the Chinese goddess of the sea.
仰望太空，浩瀚无垠，宇宙是如此的深不可测。但对于导航卫星来说，它无时无刻不与我们同在，与地面保持通讯联络。只有恰好的轨道位置，恰好的通讯频率，才能让卫星发挥作用。由于起步较早，美国与俄罗斯占用了80%的黄金导航频段，给中国留下的发展空间所剩无几。
In June 2000, the UN International Telecommunications Union, ITU, squeezed out the last ban from the aerospace navigation frequency and opened it for equal access to the whole world. Under the international rules of first come, first served, and invalid if expired, the frequency had to be put into service within 7 years. This meant that China would have to successfully launch a satellite that could transmit signals before April 17, 2007. Otherwise, all the efforts and hopes put into building BeiDou into a global navigation system would be for nothing. The development of BeiDou 2 had just started. It was now a race against time. In 2005, the development and manufacturing of BeiDou 2 satellites entered its most intense stage. But the domestic rubidium atomic clocks available for the satellite were still unable to meet demand. Space-borne rubidium atomic clocks provide navigation satellites with a standard for time and frequency. It is a core component that determines the foundation of satellite positioning and the accuracy of its time service. For the first BeiDou 2 satellite, it was planned to use 1 domestic rubidium atomic clock and 3 imported ones. However, back then, Western countries prohibited the sales of basically all high-tech products to China, including rubidium atomic clocks. After negotiations, only one European company said that they were willing to sell the atomic clocks to China, but continually raised the price. On top of that, there were constant problems with the clock's performance, quality, delivery speed, and service guarantee. On the last day of May 2005, the BeiDou 2 engineering team finally made the tough decision to replace the 3 imported rubidium clocks with domestic ones. At the time, BeiDou 2 had less than 2 years to launch in order to keep the frequency. This was a huge and unexpected challenge. Before then, domestic rubidium atomic clocks had only been used as backups. Several science and research institutes began working on a mission that seemed impossible to complete within 1.5 years, producing spaceborne rubidium atomic clocks that belonged to China. Laboratories became silent battlefields.
"此次发射的实践8号育种卫星是我国发射的第23颗返回式科学技术试验卫星。星上搭载有粮棉、蔬菜、林果、花卉等9大类2000多份农作物种植材料。
In September 2006, the Shenzhen-8 satellite was launched into space, carrying 215 kilograms of seeds. What many people didn't know was that the satellite was also carrying a domestically made rubidium atomic clock. The clock operated for 13 consecutive days in space, with data tests all returning normal results. After overcoming a mountain of technological setbacks, at 4:11 a.m. on April 14, 2007, the first BeiDou 2 satellite was launched over 6 months earlier than scheduled. According to the rules of the ITU, the right to use the frequency band is only recognized when the signals transmitted from the satellite are received. Everyone's attention was on the clock. In order to obtain the frequency band, the satellite had to send back signals within 68 hours, while in orbit, debugging usually takes 7 days. At 8 p.m. on April 17th, the receiver interface suddenly flickered, and BeiDou 2 sent back the first group of clear signals over 60 hours after the launch. There were less than 4 hours to go before the final deadline. BeiDou 2 had entered the Global Navigation Satellite System Club at the last moment, before the door was shut for good. After walking this difficult path, BeiDou finally began to show its great power. Since November 2017, China has launched 30 BeiDou 3 satellites and 2 BeiDou 2 backup satellites in 32 months, with a 100% success rate, and setting a new record for the launch of a global navigation system network. The BeiDou 3 today continues to use the mixed constellation design of BeiDou and its short message communication system. With a world-leading inter-satellite link, signal system and highly accurate domestic spaceborne atomic clocks, its core components are completely autonomous and controllable. The satellites now have a lifespan of over 10 years, with a positioning accuracy of within 10 meters, and a time service accuracy of within 20 nanoseconds. it is able to provide countries around the world a diverse range of services, including positioning, navigation, time service, short message service, and international search and rescue. In the summer of 2020, the UN Committee on the Peaceful Uses of Outer Space said in its congratulatory letter to the BeiDou Global Network, this result is only possible with a long-standing and sustained commitment to space.
当北斗3号工程完成全球组网时，很少有人知道，全国有400多家单位，30余万名科研人员参与其中。2020年，距离曾经的灯塔计划已经过去了有50年，距离陈方允先生提出的双星定位构想过去了37年，距离北斗1号工程立项过去了26年。回首往事，我想所有的航天人会在内心感叹一句话：不容易。我们也会感慨，北斗这个词汇仅仅是指太空中那7颗星体和我们组网的50多颗卫星吗？是，也不仅仅是。北斗之于中国，已经早已超越了其工程本身的精神内涵。
On July 31st, 2020, the completion and opening ceremony of the BeiDou 3 global navigation satellite system was held in the Great Hall of the People. That year, Sun Jiadong was already 91 years old. The younger generation of practitioners in the aerospace industry stood beside him, preparing to extend BeiDou's path further into the future.
我宣布，北斗3号全球卫星导航系统正式开通。
Innovation, integration, solidarity, and the pursuit of excellence. The people who built BeiDou gave the best of their lives to their ideals and this great undertaking. They illuminated the way forward for the country and showed the Chinese people the BeiDou spirit of the new era.